Alright, my friends, so we are going to do some problems where we're solving multiple angles. If you need to pause the video right now and copy these steps down, feel free to do that. It's my sincere hope that you understand all the steps that are on the page so far. If not, do pop into office hours Tuesday, Wednesday, Thursday, or Friday. Once we get to this point, things still are going to be relatively similar. I need to figure out when the cosine of an angle is equal to 1/2. So I'm definitely going to use the idea that cosine is the horizontal component of the reference triangle in my unit circle, and that this is the short side of that triangle. So in my head, I'm picturing this beautiful unit circle. The horizontal component is going to be the short side of a 30, 60, 90, and I'm going to have two triangles that can do that. Now, so here's the difference, and I think this is not going to be too surprising. Instead of saying t equals whatever this angle is and whatever this angle is, I'm going to say 3t equals those things. So 3t is going to equal pi over 3 plus a full rotation, and 3t is going to equal 5 pi over 3 plus a full rotation. Now, I said in the other video we'd be looking specifically between 0 and 2 pi, and that is what's going to happen for this example. But I want to say we always start by trying to find some kind of expression that could catch every single answer. And then we use that expression to figure out, okay, if this is all possible answers, which of these answers actually fall between 0 and 2 pi. And it ends up being a lot of algebraic manipulation, a lot of getting comfortable with abstract symbols. And I've got some tips and tricks that I used to help me when I was learning this that I'm going to share with you guys. So we are going to still kick it off with, let's get those two reference angles that hit those, those specific triangles. Let's add that full rotation if it's cosine or sine. If it were tangent or cotangent, I'd be adding a half rotation because the period for those graphs is different. And I'm still in Algebra 1 mode in the sense where I'm is my unknown isolated yet? And of course I can look at the left side of either one of these equations and see that t is not by itself yet. I'm going to have to divide both sides by 3 to make that happen. So this is the time in my life when I started to really appreciate fractions, because it's going to be much easier for me to think about multiplying everything by 1/3 as opposed to dividing by 3. Because I'm already going to have fractions in my answer. There's no getting around that. That's how this trig stuff's going to work. And rather than take pi over 3 and dividing it by 3, I can think about multiplying by 1/3, or better yet, tripling that denominator as opposed to dividing by 3. So that's what I'm going to do. Both sides, right? I'm going to multiply this side by 1/3 and multiply everything over here by 1/3. So these will cancel. And that means that t is going to equal what happens. I'm going to triple that denominator. Pi over 9 plus 2 pi n over 3. And I'll do the same thing over here. So before I do that, just so you can see it's not that bad, why don't you pause the video and write lightly, or pause the video and think about what's about to happen. And I'm going to go ahead and slowly bring my pencil over here to give you time to pause. And now you maybe resume to the video. So 1/3. These will cancel. And t will equal 5 pi over triple that denominator plus 2 pi n over 3. Now the second thing that I learned how to do with fractions that made me and it was in this kind of a class where I learned it. Even though I knew about fractions in 4th and 5th grade, never had to work with them like this before. We know that when we add or subtract fractions, it's super important to have common denominators. And so the other thing I'm going to do actually is get both of these right sides written as one expression by getting these pieces to have common denominators. What I'm going to do is make this denominator a 9 as well. So I'll multiply it by 3 and 3. And that'll give me, now that these denominators will match, I can write them all as all over 9. as like just one fraction. And it's going to make the last part of this problem much easier to deal with. So I'm going to say t equals pi plus 6 pi n, that entire thing over 9. So I don't want to like go crazy. I don't know how your eyes are viewing this right now. I know how I saw it the first time I saw it. It was scary to me. And I'm like, wait, but back in 4th grade I learned I can actually add fractions together if the denominators match. If I want these denominators to match, this would have to be 3 times bigger. Let me do top and bottom by 3. Think about one thing at a time. And this was new. So like, if I'm going to take this and add this, I can do it if the denominators are the same, and I get an expression on top, pi plus 6 pi n. So again, take a moment, pause the video. It's going to look very similar over here. I'll slowly drag my pen over while you're pausing. Hopefully now you paused, now you resumed. I want these denominators to match, so this will have to be 3 times bigger. So that would give me a beautiful, come on now, 5 pi over n plus 6 pi n over 9. So t might also equal 5 pi, plus 6 pi n over 9. So that's good. I'm in a very good place right now. And I know how crazy it looks, but when I think about each individual step, it's not that bad, right? One thing at a time. So if I wanted all possible answers, I would stop right here and say, done. We're finished. And I'd box that and be very proud of myself. If I, though, want answers between 0 and 2 pi, what I'm going to need to do next is let n equal 0 and 1 and 2 and 3 and all kinds of things to figure out how to get the actual answers. I'm going to do that in a separate video in the next video. So if you understand everything up to this point, you're good up to this point, and if not, give me a question. Let's watch the next video to see how to actually take this all answers and instead convert it to answers that are strictly between 0 and 2 pi. Hopefully it'll be a shorter video. Let's see.